All right, today we're going to dive into the hidden world of electricity. We're going to start with a spark so small you can get it from a lemon, and we're going to scale all the way up to the massive grid that powers our entire society. Ready to see how it all connects? Let's jump in. I know, it sounds like a bit of a riddle, doesn't it? But the answer is really at the heart of our story today. See, both a simple lemon and a massive power station can generate electricity. But how? And what does it take to go from powering a tiny little light to an entire city? That's exactly what we're about to find out. So, to really understand the big picture, we have to start small. In this first part, we're going right back to the absolute basics, the fundamental rules that make literally every single electrical device work. Okay, this right here, this is the golden rule of electricity. For it to do any work, like lighting up a bulb, it needs a complete, uninterrupted path. We call that a circuit. Think of it like a racetrack. If there's a break anywhere in the track, the cars can't finish the race. It's the exact same idea with electricity. There can be absolutely no gaps. So, what makes up this racetrack? Well, you've got four main players. You've got the battery, that's your power source, the starting line that gives everything a push. The wires, that's the path itself. The bulb is kind of like the finish line. It's the thing that does the work. And the switch? The switch is the gatekeeper, the controller that can open or close that path. Okay, so you have your components, but how you connect them, well, that has huge consequences for how the circuit actually behaves. Let's take a look at the two main options, because the choice between them is the difference between festive lights that work and the ones that drive you absolutely crazy. And this just illustrates the core difference perfectly. A series circuit is basically a one-lane road. All the electricity has to follow the exact same path, going through one component after the other. A parallel circuit, on the other hand, is more like a multi-lane highway. The electricity can split up and take a bunch of different paths at once to get where it's going. So, why does this matter so much? Well, in a series circuit, that one-lane road, if one bulb breaks, the entire circuit is broken. The whole thing fails. Remember those old fairy lights? One bulb goes out, they all go out. But in a parallel circuit, if one path is blocked, the electricity just says, no problem, and takes another route. That's exactly why our homes are wired in parallel. A light can burn out in the kitchen, but the TV in the living room stays on. And, just as important, each bulb gets the full electrical push, which we call voltage, making them all much, much brighter. Now, we've been talking about wires and batteries, but you can also generate electricity through chemistry. So let's go back to that lemon and see how we can actually turn a piece of fruit into a power source. This is such a classic experiment, and it's pretty brilliant. You just take two different metals, like a copper coin and a zinc nail, and you stick them in the lemon. The citric acid inside the fruit acts as an electrolyte, which is just a fancy word for a liquid that helps electricity move. This kicks off a chemical reaction where tiny electrons start flowing from the zinc over to the copper. And that flow of electrons, that is an electrical current, and it's just enough to power a small light. And the result? A single lemon can produce about 0.9 volts of electricity. Now, that's not a lot, but it's real, measurable power. And yeah, if you connect a bunch of lemons together in a series circuit, you can add up their voltages. But to put it in perspective, you'd need a chain of over 1,000 lemons to power just one standard light bulb for an hour. So, while it's amazing, it's not exactly practical for lighting your home. So, if 1,000 lemons can barely power one bulb, how in the world do we power an entire country? Well, to do that, we need to scale up. Way up, from kitchen science to a massive nationwide system, the power grid. The whole journey is basically a 5-step process. First, power is generated. Then, and this is the really clever part, its voltage is stepped up to an incredible 400,000 volts. Now, why so high? Because at a super high voltage, electricity can travel for long distances with way less energy lost along the way. Think of it like really high-pressure water in a pipe. Then, as it gets closer to our towns and cities, it's stepped down at substations until it finally arrives at your wall at a safe, usable 230 volts. So where does all that generated power actually come from? Well, in South Africa, as this chart shows, the picture is pretty dominated by one source. Around 70% of the country's electricity comes from burning coal, with renewables like solar and wind making up a growing, but still much smaller slice of the pie. And this brings us to a question many of us are all too familiar with: load shedding. It's a direct result of this energy mix and the state of our infrastructure. When the demand for electricity, what everyone needs, is more than what our often aging power stations can actually supply, the entire grid is at risk of a total collapse. So to prevent that catastrophic failure, power is intentionally cut to different areas on a rotating schedule. This brings us to the final and, maybe the most important part of our story. Electricity isn't just a technical system. It's a lifeline. It has profound effects on people's lives. And making sure everyone has access, that's a major challenge. When we talk about fairness here, it's so important to understand the difference between equality and equity. Equality means giving everyone the exact same thing. Equity, on the other hand, means giving people what they specifically need to have a fair shot. For example, a health clinic that needs to power refrigerators for vaccines has a much greater need for reliable electricity than a single small home does. A truly fair system recognizes that and provides support based on need. So here's the bottom line. Access to reliable energy is fundamental. It means kids can do their homework after dark. It means life-saving equipment in hospitals can run without interruption. It means businesses can operate, create jobs, and connect to the global economy. It is literally the foundation of modern safety, health, and economic progress. And the good news is that there are some incredible solutions being used to bring power to remote and off-grid communities. We're talking about small-scale, sustainable technologies like solar panels, biogas digesters that turn waste into fuel, and even simple solar lanterns. They're making a huge difference where the national grid can't easily reach. And that really brings us full circle, doesn't it? From understanding a simple little circuit with a single bulb all the way to imagining a grid that powers a whole nation, the goal is ultimately the same. It's about so much more than just making a light turn on. It's about creating opportunity and building a brighter future for everyone.